Let's take a moment and review some of the ways people have injected liquid nitrous into a combustion engine. Behind me, I have a diagram of one of the oldest ways and one of the ways that's still being used today. Let's start off with naming the components on this diagram. Right here you have a nitrous bottle, you have a solenoid, then you have a fuel vessel, you have a fuel pump, you have another solenoid, and then right here you have a nozzle. Okay, now the goal is to get fuel and nitrous to come together, mix, and go into the combustion chamber. This is how they've done it in the past. Here's your nitrous bottle. What they do is they'll heat this nitrous bottle up so that they can get the pressure on the inside of the bottle to 900 psi. Now the pressure's up to 900 psi. As they activate the nitrous switch, it will open these two solenoids. As those two solenoids open, the fuel pump will once again start pumping fuel, and the nitrous pressure has all this pressure in the bottle which pushes the nitrous down the line, past the solenoid, and down into the nozzle. In the nozzle you'll see these two little jets. You'll have a jet for the nitrous and you'll have a jet for the fuel. Okay, let's talk about some of the ways that people have struggled trying to inject nitrous into their engine using this method. And the number one struggle would be the pressure in the nitrous bottle. See, as soon as you activate your nitrous switch and you open these solenoids and that nitrous starts to move, the pressure starts dropping. As that pressure inside of that bottle starts dropping, your ratio between your fuel and your nitrous starts to fade, meaning that your nitrous spray becomes weaker and weaker because your pressure is going down in the bottle. Now, what are some of the ways that they've came up with to try to solve this problem? Well, first off, let's just say you hit your nitrous button and your pressure drops in your bottle and you let out and you're ready to try to hit your nitrous button again. The pressure is already down in the bottle, so if you hit your nitrous button again, your nitrous and your fuel ratio is going to be off. You're not going to have as much nitrous pressure. So what they got to do is they got to get the pressure back up in the bottle. And the way they do that is by temperature. See, the outside temperature of this bottle dictates what that pressure is on the inside. So what they've come up with is, I think one of the oldest things they've done is they take a torch and they light the torch, they have a flame, and they sit and heat this bottle up, and they watch their pressure gauge. And as that pressure starts going up, they set the torch down and they hurry and hop on the vehicle and they take off and they activate their switch for their nitrous run. Another way that they've controlled the temperature of that bottle is by what they call a bottle blanket. So they'll wrap this bottle right here with this blanket, and this blanket has heat to it. So they turn this little switch on and it heats up the bottle, which brings the pressure up. Now, one of the challenges with this bottle heater is the minute you activate your nitrous switch, the inside of the bottle chills instantly and the pressure goes down. As soon as they let off, if they wait long enough, the bottle heater will raise that temperature back up, which brings that pressure right back up again. What happens if they get the temperature too high? Let's say 90 degrees brings you up to 900 psi. What happens if they get up to 1500 psi? Well, if they were to activate their switch when their pressure was too high, now their ratio would be off the opposite direction. Now they would have too much nitrous and not enough fuel to cover it. So what they do is they put another solenoid in line right here with a separate button. So what they got now is they're looking at their gauge and they see that it's up to, let's say, 1500 psi. They'll touch this little button, which they call their purge, and they exhaust nitrous out of the cylinder, which drops the pressure down. So once they got it down to 900 psi, then they know that they can take off and use their nitrous spray. Now, one of the other ways that you can get in trouble with this type of a system is, let's say you don't have a gauge on your system, and so you read in your little book that it says use this nitrous jet and use this fuel jet, and it will give you the exact AFR that you're looking for. So somebody who doesn't have a lot of experience puts this whole system together and goes out on the racetrack or out in their field or out down the street, and they pull the trigger and the bike stumbles like it's got too much fuel. In their mind, they may say, well, my jet sizes may be off. So the first thing they do is they go back and they pull this jet out and they replace this jet with a smaller jet so that it's not giving it as much fuel. And then they let their vehicle sit out in the sunshine. As this bottle temperature starts going up, the nitrous pressure starts to increase. And what they thought is they had too small or too much fuel, but in reality their nitrous pressure wasn't up to 900 psi yet. It was low. So when they shot the motor, it felt like it was rich on fuel, which it was. So they changed the fuel jet and go smaller, but unbeknown to them, their pressure as it sat in the sun has went back up. Now they're getting ready to make another nitrous run, and they don't know that this fuel jet is too small because now their pressure is back up to where it needs to be. They pull the trigger, the motor goes lean, they cause damage to the motor. One of the other reasons that this system can be difficult is these lines from the fuel solenoid and the nitrous solenoid going into their nozzle. Sometimes these lines are long, sometimes they're short. This depends on who puts this system together. But what happens is when they let off the nitrous, these solenoids close. There's still fuel and nitrous in these lines right here. So the nitrous at 900 psi is going to evacuate very rapidly. But the fuel, this fuel pump, for example, is probably pumping about 6 psi. Well, there's still fuel here, so the solenoids close off, the nitrous exits the system, but there's still fuel sitting right here, and the vacuum of the motor continues to pull this fuel into the combustion chamber, and now you're getting extra fuel in your motor. It acts like it's rich, it gurgles, it stutters, it causes problems. It's not really clean, the on and the off. Another thing is, since you do only have 6 psi and you're shooting for 900 psi, the minute you activate your system at 900 psi and 600 psi, which side is going to get to the motor the fastest? At 900 psi, my bet is that the nitrous spray is going to beat the fuel at its 6 psi to the motor, and for a split moment in time you could experience nitrous before the fuel. Once again, that can cause damage to the motor. It goes lean. It also causes popping, all kinds of hiccups in your motor. With that being said, let's take a look at some of the new ways that Boss Noss have come up with, which we call our breakthrough technology. And you'll probably agree with us that it really is breakthrough technology, because all these problems that you could have with this system right here, we have addressed these problems. So we're going to jump to the next video. Come and see us there.